Okay, so we're on to the connecting rod. This has a big end, a small end, a cap, has some screws to hold that cap together with. This thing comes apart and it actually has some little sleeves in here. There's a little divot when you're putting these in to keep them in place. So this just really helps keep the friction lowered on this. There's a sleeve up here too. How this thing is going to fit in. So we had our piston and there was a wrist pin that goes in here. I actually had to hammer this thing out, but this wrist pin goes in and the connecting rod, the small end of the connecting rod is going to fit inside of that piston. So this wrist pin is going to go into the piston and then through the connecting rod. So as we're putting together these things, all of the machine parts, they have to fit into one another. So once you have that first part in, everything else is going to have dimensions that are based on that. A couple things to notice. This thing is actually much, much heavier than the piston. This is very lightweight. It's made out of aluminum versus our connecting rod is much heavier. It's made out of a steel. And the design of this, it actually has some kind of ribs at the end. It's like an I-beam. And the I-beam is used in connecting rods the same way it's used in bridges. So if I want to bend this thing, what you get is a tension on one side and compression on the other side. If this is going to break, the breaking part happens right at the edge of it. Like the largest force is right at the edge, not in the middle. So when you want to reinforce it, you put the most material possible at the edge of this thing. And that goes if you take mechanics of materials, or it's a moment of inertia calculation, actually. Moment of inertia goes for rotational motion and beam design and how difficult it is to bend these things. Walking through the dimensions of this thing. So the wrist pin has a diameter of 7/8 of an inch. That will be the inside diameter on the small end of the connecting rod. Over on the other side, our crankshaft is going to have a diameter of 2.25 inches. And the easiest way to start creating this is to draw these two circles and then look at the length of the connecting rod. This length will go into the engine design, the engine block. It's determined by the stroke length and compression ratios that are allowable by the fuel. So this actually gets into chemical engineering of looking at what pressure the fuel-air mixture will ignite at for a diesel engine versus gasoline. So diesels can have a much larger compression ratio, larger connecting rods, actually a little bit more energy efficient too. Okay, so the diameter versus the thickness, it's kind of a little square here. So 7/8 inch diameter, and then we'll extrude that up to a height of 7/8 inch too. And that will fit snugly inside of our piston. We'll sit right up here on the top. We'll make a rectangle here to connect it to the larger circle. The center to center distance ends up being 7 inches minus this thickness minus the radius. So it's 6.5625, a little bit odd of a distance here, but that's what I got off of the connecting rod. And this is controlled by the type of fuel that's in there and some of the geometry of the engine block itself, what that stroke length is going to be. So odd dimension, but we can start with that center to center distance. We'll then bump out these sides that will hold the bolt. So 1.75 inches, we'll have 1 inch on the top, 3/4 of an inch on the base, and we'll bump this out 1/2 of an inch to accommodate the 3/8 of an inch bolt that is going to connect these together. So part of design is manufacturability. You have to understand how the thing is going to be assembled in the lab. So you can see how the connecting rod is connected to the piston on one side. You slide the wrist pin in here. You've got a little pin to hold it in place. On the other side, the crankshaft, you'll actually have to assemble it around that crankshaft, so bolt it in place on the other side. So I've opened up another file, IPT inch template. Be careful what you name these files. The names of the files can be pulled into our IDWs in the future as the file names and the part names. And so use something like the piston from the Acura, some kind of title that will look good on your parts list. I'm going to start with the small end on the right-hand side. So again, you can put these dimensions in terms of fractions. So 7 divided by 8, that's going to fit around my wrist pin. And then the center to center distance for the two ends of this thing is going to be that kind of odd dimension. So 6.5625 inches. And I'm making that with a construction line, and I'll add the large end over here. So this guy has a diameter, inner diameter of 2.25 inches. I can then start using the offset command. So 1/8 of an inch wall, and we can offset the center 5/16 of an inch, and again 5/16 of an inch. Let's bump out the large circle by 1/4 of an inch. I'm going to put the sides on where we're going to bolt this together. This is the radius plus 0.5, so 1.625. We're going up an inch. I'll just overlap this and trim it out later. On the other side, we're coming down 3/4 of an inch, 0.75 inches. And we'll connect these guys with an arc underneath here that's 2.5. If you look to see where that arc ends up. And I'll go ahead and use one of these 3 points arc. So the first and second points are where it starts and stops, and then you can adjust how thick that is. Okay, trimming out a few things here. And what we'll do is use the offset. Before offsetting, go ahead and make sure these two lines are connected to one another so that they will offset connected to one another. And I'm going to bump this down 1/8 of an inch. Now, I only want this rim on the handle, not around the upper part. So I'm going to see if we can trim in. Some of these you'll have to really zoom in. So use the rolling button, the scroll button on your mouse to zoom in so you can see how those lines are coming together. And Inventor and CAD, even 3D printing, does not like to have really, really sharp angles like that. So what I'm going to do is just draw a 1/4 inch circle and use the constraint commands to bump that up and kind of fillet edge. I'm not sure if the fillet command would work for that sharp of a corner, but that will give us just a nice way to come together. And then I'm going to go ahead and try and close this loop so that I can then mirror all of this around to the other side. So let's see, finish off some trim command, get everything really nice before adding up the mirror command, and decide which piece of this you're going to send over. So I'll go over and send just this offset arc. and everything that the bolt is going to go through. So we'll mirror all of that to the other side. Okay, let's trim out what we don't need. And I'll use this as a basic sketch in the future and copy it into a couple different sketches and do this extrude in a couple pieces. Looks like we're missing part of that circle. So I'm going to go ahead and just, I'll delete this whole thing out and just redraw that large circle that we used to get that. We've got some points here to snap it to. Sometimes it's easier just to redraw something than to fix a missing chunk of a circle or something. Okay, so that's a good start on this. We'll go ahead and save it, save often. I'm going to extrude this in 3 parts. 1, just the circles, 2, the edge, and 3, the inside of the beam. Those are all slightly different heights. So I'll go ahead and extrude these circles first, and these are the ones that are really going to fit inside of the piston over on this side, and will fit into the crankshaft on the other side. This is a really nice feature of AutoCAD, that we can extrude it around the center. You can actually define how much it's going one distance versus another distance. So we're going to have a height of 7/8, or each side would be half of that. So 7 divided by 16 and 7 divided by 16. So it's going to evenly extrude it from each side. And at the end of this, if you go to Tools, there's a little measuring tape, and you can make sure that that extrude height is the 0.875. So again, it's telling you the distance from the center to the top and from the center to the base. So use that little measuring tool if you want to check on things. Okay, underneath that extrusion is our old sketch. I'm going to go ahead and open that sketch up again, and I'm going to copy it onto a clipboard and onto a new sketch. So I will select everything. I'm just clicking down my left mouse button and getting everything in there. I'll use the base point as an origin. That's an easy point to use. So I'll say done. It's now on my clipboard. And then I'm going to go ahead and open up a new sketch right on that same plane that it was on before. So Control V, and I now have my drawing again. And this time I can go ahead and extrude the edge of it. So extruding the edge, and I'll go ahead and pop up here where my bolts are attached as well. And same thing as before, so I will extrude this through both sides. And this time we'll choose a distance of 1/2 inch. So that is how far out we came from the side on this thing. So that will give us kind of a nice square extrusion on the top. Okay. I'm going to then open up this sketch a 3rd time, copy it onto a clipboard again, and we'll get to the very center of this as our last piece. So choosing the origin as our base point again, and opening up a sketch on that same working plane again, Control V, finish sketch, and the final piece we will extrude the center part symmetrically, and for this time I'll make it 1/4 inch on each side. So just give it a little bit of a lip in there. Not too bad. Okay, make sure you're saving through all of this as well. We can come up here and now drill holes for our threaded fastener. So I'll go ahead and start a sketch on the top here. And for our circle, and we're going to want to give ourselves a little bit of a clearance here. So if I come down 1/8 of an inch, that's the distance we have been giving ourselves. And then I come down another 1/2 of 3/8. So that would be 3 divided by 16 instead of 3 divided by 8. And that will give us a good spot to put the hole for our screw. And as we drill this through, we'll make sure it's going to come close to the edge, but then extruding this through, making sure it's a hole. And that's where our threaded fastener will make it through on this thing. Once we have one side done, we can use the mirror command to get this to the other side. So features, extrusion 5, mirror line. We can choose the XY plane. This is a nice thing to always keep your parts centered around the coordinate system. It makes everything just so much easier. Okay, the final thing I'm going to do, I can fillet edge to curve a bunch of this stuff around, and then I will save this as 2 different files, one for the top and one for the handle. Trying out some fillet edge just to smooth some corners down before I carve it up. I'm using a radius of 1/20th of an inch. So 1/16, that would go halfway through the 1/8 on each side, and there would be no flat surface left on some of those 1/8 borders. So 1/20th will make sure that none of these guys come together in the center. And this is just kind of telling everybody at the machine shop which has to be exact and actually fit inside. So the tops of those circles, those do have to fit snugly in the crankshaft and in the piston, but the rest of it, it's not actually fitting into another part. So round those edges off. They don't have to be machined exactly or sanded down or anything. It's just the parts that are rubbing against other pieces that need to be exact and have a really good surface for this guy. Okay, so now I'm going to save 2 pieces, one as the top and save as a new name, one as the base. And I'll go ahead and edit these guys. So for the base, I'll carve away just the top of this thing, and I'm going to just leave it as is and do one more extrusion that gets rid of the top, so only the base is left on there. And I can then open up that second copy that I had that I saved as the top, and I'm going to do the same thing with the top. So again, I'm just going to get rid of everything except for the top. And that'll make sure that the top and the base fit snugly together with one another. So this will be the easiest way to make those 2 pieces. Okay, so now we have the connecting rod, top and base. We have our piston, and just make a few IDWs to finish this out.